Here are the answers for the day 4 warm-up. The electrons in a covalent bond may not be attracted equally by each atom because those atoms have different amounts of positive charge in their nucleus and different amounts of lower level electrons that shield the positive charge. Those were the factors that cause the electronegativity of an atom. Determine if each bond is nonpolar or polar. If the bond is polar, then use the delta positive and delta negative symbols along the covalent bond to show the direction of polarity. Question A, we have a molecule of fluorine, F2. Because each atom participating in the covalent bond is fluorine, the difference in the electronegativities between the two atoms will be 0. If you look up the electronegativity value of fluorine, whatever that number is going to be the same for the fluorine on the left side as it is for the fluorine on the right side. When you subtract those numbers, the result is 0, meaning there's no difference in their electronegativities. They're identical atoms. So neither of the fluorines will pull the shared electrons closer to itself. The electrons will be shared equally between both atoms. That single covalent bond is a nonpolar covalent bond. It's not polarized, meaning it doesn't have one end of the bond which is positive and the other end of the bond which is negative. Now question B, we have a drawing of a water molecule. There are two single covalent bonds in this molecule. Are those bonds polar or are they nonpolar? Well, it all has to do with whether the shared electrons that are shown with the dashed lines are being shared equally between the hydrogen and the oxygen atoms. Or maybe the shared electrons are pulled closer to one of the atoms. Look up the electronegativity value of hydrogen on page 181. Then look up the electronegativity value of oxygen on page 181. The numbers aren't the same. Oxygen has a higher electronegativity value, so the oxygen atom will pull the shared electrons in closer to itself. The shared electrons will be farther from hydrogen's nucleus. This results in polar covalent bonds. Polar covalent bonds can be labeled to indicate which end of the bond is positive and which end of the bond is negative. Because the shared electrons get pulled closer to the oxygen end of the dashed line will be negative. And the hydrogen end of the dashed line will be positive. The same labeling can be done on the other single covalent bond. The oxygen end of the dashed line is negative and the hydrogen end is positive.